This is Always Eclectic Stacy. Welcome to 5-Minute Chemistry. This is the covalent bond series, and this is the fourth example of taking the covalent name and writing it into a molecular formula. Let's go. The fourth example of VSEPR and Lewis structures where we talk about molecular geometry. This one's going to be carbon dioxide. So remember, the first thing you're supposed to do is determine if it's polar or nonpolar. So I'm going to look at carbon, and it has an electronegativity of 2.5. And then I'm going to look at oxygen. Has an electronegativity of 3.5. When I subtract them out, the difference is 1.0, which should make this a polar molecule. Now, as we've discussed, chemistry can be funny, and depending on molecular shape and how the molecules are pulling, they actually may determine nonpolar, even though the electronegativity says they should be polar based on shape. So let's kind of look at this. So the first thing I'm going to do is draw the Lewis dot of carbon. And carbon, remember, has 4 valence electrons. So that's going to be carbon with 1, 2, 3, 4 dots around it. Remember, it goes right, left, up, down for Lewis dot. But we can change it up for Lewis structures depending on where the bonds are. Now for oxygen, I know there's 2. I'm just going to write 1. It's right, left, up, down, right, left, because it does have 6 valence electrons. And remember, we put the one with the most bonding potential or the least electronegativity in the middle. So this is carbon. It has 4 bonding potential, so that's going to go in the middle. Oxygen has 2 bonding potential, and remember, the single dots show you the bonding potential. So carbon's going to go in the middle, and I'm going to put an oxygen on either side. I'm going to go ahead and fill in those lone pairs for oxygen so that we can get an idea. Now remember, each oxygen can make up to 2 bonds, 2 single or 1 double, and each carbon can make up to 4 bonds, 4 single, 2 doubles, 1 triple and a single, and 2 singles and a double. But seeing this can take a double bond and this can take a double bond, we're just going to go ahead and throw in the double bonds, and then we can count. See if they're all happy. 2, 4, 6, 8. This oxygen is happy. 2, 4, 6, 8. This carbon is happy. 2, 4, 6, 8. This oxygen is happy. So we're happy. Now we're going to look at the molecular geometry, and we're going to, remember, only look based on our central atom, which is carbon. So this has 4 bonding pairs. With 1, 2, 3, 4, it's going to have no lone pairs. So this is going to be a tetrahedral. That's the molecular shape. Now, I was going to go in and draw the dipoles because remember, it's supposed to be based on electronegativity a polar molecule, but because it's carbon in the middle with each oxygen on the side, so it's going to be pulling equally, and it's kind of more of a straight line tetrahedral, this is going to go ahead and be a nonpolar molecule because the poles kind of cancel each other out and make it nonpolar. This is the fourth example of VSEPR and Lewis structures. I hope you learned something today.